Hello and welcome to the second part of the tutorial for creating water effects in MayaLT. In part 1 we generated normal and displacement maps, but because of the way we did that, the images are not tileable and we cannot use them to build a shader. To demonstrate this really quickly, let's create a polygon plane and scale it up. Let's hide the grid and assign a new material. And for the color, we're going to plug one of those two files from part 1. These two right here were the ones generated previously, so let's select one of them. If we take a look, right now it doesn't look too bad, but if we go to the placement node and we start to play around with the offset, you can notice a very obvious seam. So we cannot use this texture to build a shader because to animate the water, we're going to use the offset, UV offset. And obviously this would not look good at all. So how can we fix it? You can open the images in your favorite image editing software, and what you see right now are the images as they were generated by Maya. The first thing that I did for both of them was translate them with an offset, making sure that at the edges the image wraps, just so I get exactly the same seam in the middle, just like in Maya. The second step is to build a sort of mask just around the seam, because we want to get rid of the pixels inside of this mask. Don't forget to blur your mask a bit, because otherwise you'll just have another set of hard edges instead of just, let's say, two, horizontal and vertical. You're just going to have more in the shape of your mask, so blurring your edges is important. And then what I did was just delete these pixels. If you have the time and the skill, you can try to paint them out by hand using paintbrushes or clone tools. But what I did was just delete them and then combine the result with the original image. The result, if we compare the offsetted image with the processed one, as you can see, it's only the seam in the middle that disappears, and we preserve all of the detail. And it's the same thing for the displacement map. This was created exactly in the same method. So let's go back to Maya and start working on the shader. Let's start with a new scene. Let's create a polygon plane. And if I remember correctly, previously the size was around 50. And we only need one division because the detail will be generated using normal maps. Let's get as much screen space as possible. So select the plane and let's assign a new material. For the final shader, I'm going to use the Stingray PBS shader. PBS stands for physically based shading. It's a more advanced shading technique. It gives a better result without too much work. And also I'm going to take advantage of the fact that the Stingray PBS shader has an environment already built in. If you're trying to create the same kind of setup with the shader effects shader, you're going to have to deal with the environment yourself. You're going to have to figure out how to make reflections, because reflections are a very important part of a water shader. I'm going to start with the shader effects shader though, because I would like to show you first how you can use the displacement map to generate the X11 tessellation. Unfortunately, at the moment, tessellation does not work with the Stingray PBS shader. So that's why we're starting with the shader effects. So let's open the shader effects window. For the color, let's put something that kind of looks like water, but without too much effort, because like I said, we're going to use a different shader for this, for the final shading technique. The first thing we're going to need is a float. If I can type float node and give it a value something like, let's say, 50. And okay, before we plug it anywhere, let's select the material node and enable wireframe. If you see right now, we only have 2 triangles because we only have one quad. What tessellation does, if we connect the float node into the tessellation factor, and we need to refresh a bit, as you can see, it subdivides the mesh into way more polygons. However, if we select the plane, we still only have 4 vertices, which means our geometry is actually really light and it's perfect for a game engine. The next thing we're going to do is create a displacement map node, and let's navigate to where our texture is. The last 2 images are the ones which tile, which I modified. So let's select the displacement map, and if we connect the color into the displacement port of the material, there's a pretty annoying bug where the mesh disappears, but all you have to do is just refresh the viewport, and as you can see, it's already starting to look like the surface of water. The tessellation as it is right now, it's not very good for water because the triangles do not align properly. We can fix this by adding just a couple of more subdivisions to the whole plane, and in this case a value of 50 into the tessellation factor is a bit too much, so let's lower it to around 20. Let's say 25. And as you can see, the mesh looks like really looks like water surface. We can get a better look just by disabling the wireframe. And right now, the shading of the whole plane is flat because we don't have a normal map. So let's create a normal map. And plug in the normal texture and connect into the normal plug of the surface shader node. And as you can see, the surface now looks even better than before. If you can use tessellation in your shader, by all means do so, because it will allow you to do more advanced shading. You will be able to use the Fresnel effect for reflections, transparency, and color. But like I said, right now with the Stingray PBS shader, this feature is not supported. But I just wanted to show you how you can use the displacement map that we generated in part 1. So let's start working on the final shader. We'll start with the new scene, and let's make another plane. And the same size, 50 by 50. And this time really we only need one subdivision in all directions, so just one quad is fine. Let's create a new material and make it a Stingray PBS. And as you can see, it's already set up for you, but we cannot use this as it is right now. The only thing we're still going to use is the environment, which is set up right here. Let's open the Shader Effects editor. We are going to select everything except the material node and the texture coordinate node, and right now it's asking if we want to edit the preset or we want to create a new instance. We're going to click on yes because we want to create a new instance. We do not want to edit the preset. And we're going to delete everything except these two nodes. Let's create a color first. For that, we need a material variable node. So let's create one. Let's call it color. The type is vector3. The UI order is 1. The UI order controls the order in which your attributes are going to be displayed in the attribute editor. And let's get some sort of watery color. Let's say something like this. And plug the result into the base color. One thing we need to do is select the standard base node, and in the attribute editor for the blend mode, right now it's set to opaque, we need to set it to transparent. If we take a look, all we have is a bluish plane, which is not very impressive, but it will be in a moment. The PBS shader uses two attributes to control how reflective a surface is. It's the metallic and the roughness attributes. So let's create another material variable. This time let's call this metallic, and another one, and let's call it roughness, and another one which we're going to use for transparency. Let's call it opacity. And the order we want these to appear in the attribute editor is this. So this has the UI order of 1, this will be 2, metallic will be 3, and roughness will be 4. So let's connect them. Oh, we need to set the type. The type should be scalar for all of them. And opacity, let's say 1 in the beginning. Let's say metallic and roughness. If we close the shader effects editor, you can see the attributes we just created appearing here in the order that we specified. And if you take a look, our plane is already reflecting some kind of environment. The metallic value is really intended to be sort of a boolean. It should either be 0 or 1. However, we can use something in between to get more interesting effects. Let's try. As you can see, the more you increase this value, the more like a shiny metal the surface becomes and the more it reflects. But this is too much. So let's say something around 0.75. What does that look like? To control how much the reflections are blurred, at least in our case, we're going to use the roughness attribute. If I increase this all the way to 1, right now the plane looks like some sort of plastic. A value of, let's say, 0.2 would be enough. We still get reflections, but you can see they're kind of blurred, which is what we want. So let's go back to the shader editor. Let's figure out how we can connect the displacement map. First, let's create two material variables. Oh, no, sorry, we need textures this time. So a sample texture node. Remember, in the beginning we did not delete the texture coordinate node because we still need it. Because for every texture that you're going to use, you need to plug something into the UV value. If by any chance you delete this node, you just need to create it again. Just in the search box, start typing texture coordinate and it should pop up somewhere. Let's call this the base normal map. The encoding should be set to normal map, otherwise the mesh will not look properly. For the UI order, we don't really care right now because these are going to be displayed in a different collapsible frame. And let's browse to our image and choose the tileable displacement. Sorry, normal map. We're going to use a trick. Ideally, you would have two normal maps. One which is the base with larger waves, and another one with details, which will be smaller, high density waves. But we're going to use a trick and use the same normal map. So let's just create a copy of this, Control C, Control V, and we'll call this detail normal map. And as you can see, it points exactly to the same file. One thing, Maya might not like the trailing zeros right here, so we might have to go in and delete them later. Just so we can take a look to see what the surface looks like with just one normal map, let's just apply it to the normal plug. And there is an error somewhere. Yep. Let's see if we rename the file. Oh no, the file looks okay. Oh, it's because we did not connect the UVs. Like I said, this node has to exist. So let's connect UVs and everything looks okay now. And as you can see, the surface starts to look like water and it has reflections. So let's continue. So how do we create a detailed map from the base map? Remember, the texture is tileable, so we can just repeat the texture across the surface multiple times, and it will tile seamlessly. The only effect will be more concentrated. So to do that, we need a constant scalar node, and we want to repeat our detailed texture, let's say 4 times. And we're going to create a multiply node, and we're going to multiply the output of the texture coordinate node with our value. The order is important, so connect the texture coordinate in first, and let's connect the result of the multiply to the UV plug of the detail normal map. And now we need to combine these two. There is a node called blend normals. Oh, that's right here. So let's connect first the base and then the detail. Let's make a bit more space just so you can see the effect on the surface. And we connect the result of the blend normals node into the normal plug. And as you can see, the image right now has way more detail. It really looks like the surface of a big lake or a big river or an ocean. But we are not done yet. Let's close this and let's play with the opacity a bit, because water is never completely opaque. So let's lower the opacity. The way your water looks will depend very much on your environment. Right now all I have is a gray background, so which is a bit limiting, but if you have like a nice environment, your water will look much better. We go back to the shader effects editor. What we need to do right now to make the water animated is to basically continuously change the offset of the UVs. Exactly the same way we did in Maya. If you remember, when we changed the offset UV attribute, the texture started to move across the surface. So we need to replicate exactly the same process here. To move the UVs, we're going to use a node called the panner. And we're going to use different speeds for the normal, for the base normal map and for the detail normal map. We want them to move at different speeds. Otherwise the water will not look good. So we need two of these. And we only want, at least in this example, I'm only going to animate the direction in either U or V, not in both. So we get another constant scalar with a value of 0, and let's say we're only going to animate in the V direction, so we plug 0 into the speed U of the both panner nodes. And let's create two material variables for the speed U, for the V speed of both of these nodes. So we need two of these, Control C, Control V. Let's call the first one base map speed. The type is scalar, and the UI order is, let's see, the roughness was 4, so this should be 5. And the other variable, let's call it detail map speed. The type again is a scalar, and let's plug it into the speed V of the of one of the pattern nodes and plug the other ones into the speed V of the other pattern node. Okay, let's make a bit more space. And now we need to connect the UV, the output of the pattern nodes, needs to go into the maps, but not yet. For the base map, let's just connect the output of the pattern node directly. And there seems to be a problem somewhere because, again, we forgot to plug in the texture coordinate node. Oh, we need another node called the time node, which is a value that increases constantly. So let's plug that into the time. And let's plug the same time node into the time attribute of the other pattern node. And for the pattern node which deals with the detail map, let's plug into the UV plug. Let's connect the result of the multiply node. Because for the detail one, we want the map to repeat 4 times more than the other one. And all we have to do right now is connect the output of the pattern node into the UV input of the detail normal map. Let's try to arrange this a bit. There seems to be an error here, but there shouldn't be. Oh, let's set a value 0. Oh, okay, let's just delete it and make a new one. Constant scalar, a value of 0. 0.0, and connect it into the both speeds in the U direction. And if we close the shader effects editor, we now have all the attributes here. Let's try to get somewhat of a better color for the water. You can play around with it. And let's start to animate our water. The speed should be, at least in Maya, very small values, because if I put here 0.1 and I need to play the timeline, let's give us a lot of frames. If I play the timeline, the speed, we're going at 30 frames per second, and the speed is too much, 0.1. So let's say something like 0.05. And the trick is, the detail map has to animate, but in the other direction. So let's say minus 0.05. And if we play the animation now, it's a bit too fast, but it moves in the direction that we want. So let's say this would be 0.025 and this 0.012. And if we play it now, it starts to look more like waves on a big water surface. And let's play around with the other attributes. One thing you can do, at least in Maya, to make this effect look better, is to enable color management. I have it disabled right now, but if we go to the main preferences, let's enable color management. And if you see, there was a pretty big change. If I disable it in a viewport and I enable it back, there's a pretty significant difference, and the color now looks a bit wrong. So let's choose something like this. It's a bit too shiny. If we switch the color management to the Stingray tone map, this I think is a better match for the Stingray PBS shader. So if we play it now, we have waves on a surface. And because we have tileable textures, we can just duplicate this plane, which again has only 4 vertices, so it's very light, but we can just make a copy of it and just move it 50 units because that was the side, and the seam is right here, but you really cannot tell. I think this is a very slight error in the normal map. I'm not even sure if you can see it on your screen because of the video compression, but I see a very faint line, which means the normal map needs a bit more work when we make it tileable. But in general, you can't really tell there's a seam there. So this concludes the second part of the tutorial. Like I said in the previous part, the more you play around with the values, the better your results will be. But the techniques you're going to use are the ones described in this tutorial. I hope this was useful for you. If you have any questions or comments or suggestions, please post them on the Steam forums. And thanks for watching. Bye.